Hello, this is Artem from Xerial, and I'm excited to be a part of SlugMeet 2024. For this event, I was tasked with finding a way to calculate the paintable area of a model. Doing this manually would be quite complex. Typically, you might take a simple approach and use the Mass Properties tool in SOLIDWORKS to find the total surface area. In this example, the surface area is about 2400 square inches. However, as you would expect, this is not an optimal solution when you need the more precise calculations, like excluding the internal faces that won't be painted. This is where SOLIDWORKS API and partner products can be incredibly helpful. Today, I want to show you a feature from CAD Toolset, developed by Xerial, a SOLIDWORKS solution partner product. CAD Toolset offers many features to streamline your SOLIDWORKS workflows, including managing custom properties, generating reports, automating drawings, handling bill of materials, and exporting data. For this demo, I will be using the experimental paint area calculation module. Let me start by running the paint area tool. First, I will use the default settings and hit recalculate. The tool will automatically detect and exclude internal cavity faces from the calculation. As you can see, it found an optimal paint area of around 2100 square inches, which is approximately 87% of the total surface area. The areas to be painted are highlighted in red. Let me turn off the model transparency so it's easier to see. You will notice that some of the internal faces are still included, so we'll try to improve this result. One feature we can use is the ability to add caps to certain faces. This helps close off openings and refine the calculation. To do this, we activate the selection box and select the faces we want to cap, such as S-planar faces. The tool will automatically cap them, improving our result. After selecting the faces, I will click Recalculate again. Now the paintable area has improved further, covering about 67% of the total surface area. We have excluded more cavity faces, but it's still not perfect. Another powerful feature of this tool is the ability to cast rays onto the model, simulating the paint spray. The rays help detect which surfaces would be hit during the painting process. There are a couple of options here for specifying ray direction: rectangular and spherical. I will select the spherical option and use the default parameters. After running the calculation, we get a performance warning due to the large number of rays. I will reduce the ray density by decreasing the tolerance and increasing the distance between the rays, resulting in about 16,000 rays. The calculation should take only a couple of seconds. To further refine the results, we can focus only on external faces by specifying a threshold. The threshold represents the percentage of a face hit by the rays in relation to its total area. If the percentage exceeds the threshold, that face will be considered paintable. Let's set the threshold to approximately 50% and recalculate. You can see that some faces were excluded. Now I will lower the threshold to 10% and recalculate again. This gives us a near perfect result, with all internal faces correctly excluded from the paintable area. The painted faces are now clearly visible in red, while the internal faces retain their original gray color. Calculation result suggests that around 57% of the total surface area will be covered with paint. Finally, we can save this data to a custom property for further use in calculating the amount of paint required. Thank you. Please do not hesitate to contact me if you have any questions.